Hey y'all, so we're going to be doing intro to cryptography. The first portion here just goes over the different types of algorithms for asymmetric cryptography, it looks like. Can you guess what this quote is and who said it? So if we take a look at this quote, looks like they've done some shifting here, and we can use this website and go to it, and then it'll provide us the information. So I guess we'll just do that real quick and I'll walk you through that process here. I don't know what the rules are for, let's see here, let's put that in there, solve it. Does that have anything, or do I need to paste it? Let me try going back real quick. I have the answer there, but here it is. This is the text. Oh, this is the whole quote. Oh, I see, okay. Go there, and then let's paste that in. Solve it. Oh, here it is. Today's victory over yourself. Hold on. Today's victory over yourself of yesterday. Tomorrow's victory of lesser men. All right. Cool. Cool quote. All right. That was not what I wanted. Give me some ads here. Let's go. All right. Let me go back to the screen I was at. All right. Back at the screen here. I'll download the files. Looks like they gave me a zip. All right. Let me open up my virtual box here, and then I'll just transfer that over. Okay, I have the files posted here. We'll go ahead and click on one of these. All right, so there's the files. I'm gonna open up a terminal here. Don't think you need to get connected to their VPN to use this, but you can if you wanted to. All right, so here is going over some details about different encryptions. Decrypt the file, quote one, encrypted with using AES 256 with the key. This is the key. Using GPG, what is the third word in the file? Okay, sounds like a plan. Before I do this, I'm gonna go ahead and read through this a little bit. I'll read through this first portion here, and then I'll go ahead and follow up with the answers and just like how I'm going about trying to get it. All right, so let's do that. Okay, very cool. So they talk about confidentiality, integrity, and authenticity, the reasons why we use encryption, just going over stream versus block. So block encrypted in a block like you see here, and then stream is encrypting each individual like little block there instead of like a bunch of blocks essentially. And then you have GPN privacy guard to encrypt and decrypt, and open SSL project encrypt and decrypt. Very simple. So it's asking us to decrypt the file quote 01 using AES 256 with the key, and then it provides us the key here using GPG. Okay? So let's do this. So we got task. What is this? File in quote 1. Okay, so this is going to be task 2 then. So we'll just close this out. Close this out. I'm going to go into task 2's folder. We'll open up terminal here. We've got the file there. All right, we're using GPG. So let me go ahead and grab the GPG. This is to output it. So I'll grab this right here. I'm going to pull up a notepad, and this is where I'm going to put my commands in. Just got that there. Decrypt the file in quote 01. Okay, so quote 01. Output original text. Quote 01. Okay. Just do this. That's all you need to do right there. And then okay, I guess this should work essentially. We'll see. I'm not sure if I have this installed. All right, let me do GP. Oh, forgot to put the dot there. File or directory. Oh, I think show message. Command. Maybe it's the other way around. Let's see. Take this here. Yeah, that makes more sense. It'd be like this, GPG, and then that should work out. Oh, okay, that worked. Next, we'll just put in the key here. All right, looks like it did it, and it outputted the file here. Don't waste time idling or thinking after you set your goals. All right. What is the third word in your file? Waste. Put waste in there. Does it work? Yeah. Decrypt the file in quote02 using AS256 CBC with that key using openssl. And openssl is, I think it's installed by default, so it should be easy. All right, so let's pull up my notepad again. OpenSSL quote2 or decrypting. So we use something like this. Oh, actually, we'd use something like this command here. Grab that command over here, drop that in there. Encrypted message, original file, encrypted message. So quote 02, okay. That's good. Copy that, come over here, put it in there. Test for the password, let me put the password in. Use the password key there. Okay, I think it worked. Code 02. Original message, here it is. All right, decrypt the file. What is the third word? Okay, science is the third word. Check that out. Put science in, and that seemed to work. All right, number 3. Let's take a look at number 3. Decrypt quote02, quote03. Decrypted using Camilla 256. I don't know how to say it. With the key GPG. Okay, so GPG is kind of easier for me. So this is quote 03. Check, is that a text file? Yeah, all right. And the only difference is the encryption type is not the same, so we're using 256. I'm wondering if I need to specify that because I didn't have to specify that before. Let's see. My command, come here, drop my command, and see. Oh, yeah, it looks like it's working. All right, so there it is. You must understand that there's more than one path on the top of the mountain. I'm guessing they're gonna ask for the third word again. Understand? All right, easy day. Look at asymmetric encryption. Okay. I'm just gonna read through this real quickly. All right, I'm just gonna go to task 3 folder here. They're going over RSA and the complicated math behind it. That went straight over my head, but all you need to know is that use your public key to encrypt and your private key to decrypt. And since you're the only one with the private key, then you're the only one that could decrypt it, right? Or vice versa, you use their public key. If you're doing like signatures, actually use their public key to encrypt, and then you send them a message, and then they can decrypt it with their private key, right? Yeah, so you have that as well. So anyhow, let's see this first one. Bob has received the file cipher.txt message.txt. Okay, there's the file sent to him from Alice. You can find the key you need in the same folder, and then we know that's going to be your private key to decrypt it. So how we decrypt here? Okay, here we go. So they give us this command here, and this is the command that we'll be using. Let's grab that command, come over here, drop that command in. Ciphertext. So we know that the cipher text message, that's it right there, out decrypted text. And then we're using the private key. Bob. So obviously we don't have Alice's private key, right? So can't use her private key. So we'll be using ours. To do that, we get the decrypted message. Yes, perception is strong and sight weak. In this strategy, it is important to see distance things as if they were close and to take a distant view of close things. Very wise words. All right, and so we're looking for, what do they want here? First word. Okay, so they want the first word, perception. Go over here, I'm just gonna drop the first word in there. That worked. All right, next we got, take a look at Bob's private key, private RSA key. What is the last byte of the PI? This is my private key. Oh, details. Hmm. Get a hint here. P is the prime one. The answer should be 2 hexadecimal digits. 93. I'm not sure. Nope, that's not it. 01. I'm just looking at the hash. That's obviously not it. Okay. Well, I mean, let me open it with another application. Open up with the, let's see, we got a subline in here. Let me nano it, I guess. I don't know if I can nano it. We'll try to nano it. Yeah. All right, so it's looking for 2 hex digits. That's PI. 0G. No, 0, yeah, it's 0G. See if that goes. That's OG. OG. No, that's not. Maybe it is 0G. No, it's not it. All right, I'm gonna stop guessing and read up here. Yes, what's less of the PI? The P. Oh, there's a lot of P's. P. P is prime one. The answer should be 2 hexadecimal digits. P. Here we see the information here. Oh, we gotta execute all these commands to do that. Okay, so let's consider the following practical example. Put prime numbers 157. 9 calculates. Oh no, it looks like we're creating a key pair here. So they just created a key pair. And here it shows for them prime 1, prime 2. That would be P1, P2. I don't. All right, give me a sec. I'm gonna look at this. So if you use this command here, it'll provide us the private key information. So we drop that in here and dropped it in there, and then you can see the P1 E7. Let's try that out. See if that works. E7. Yeah, that worked for me. All right. Take a look at private key. So the private key should be the same. So it's Q. Class of Q. Oops. All right, I put in 2.7 because that's P2. Okay, that was a little complicated, but got it. All right, cool. All right, so next, let's see what we got next. Got Defman-Hellman. Defman-Hellman. Oof, look at that math. It's going straight over my head. I'll give that one a shot. Okay, I got an error on this one. But we know that the answer for it is if you run this command here, it should provide you what you need. Unfortunately, when I try that command, I don't get what I need. But I was just running into an issue with that one. Let's see here. Ideally, we should be getting this 4096 and FE 4F. Yeah. So if that worked in our favor, we would be running this command, and then we'd be getting the parameter, which is 4096, and then 4F, but that's not what I was getting for some reason. All right, moving on. We got hashing. I like hashing. Something I could kind of understand. All right. Hashing. All right, I'll read through this real quick. Okay, so we got hashing, and it goes over the fact that if hashing is used for integrity, so if there's any change in the text value of the plain text message, then the hashing algorithm will show a different output every single time. So it's based off of that. And you can use HMAC, which utilize keys to further detect that hash. And looks like they're using some HMAC commands here, so should be pretty easy. Let's go to task 5 now. Task 5, open up the terminal here. And we've got, what is SHA-256 checksum of the file order.json. All right, order.json there. All right, so we'll just do text 256 SHA. Oh, wait, 256. Okay. I don't know if they set a key on there. They didn't say if they set a key. I assume they didn't, so I guess we could just remove this, right? No, that didn't work. Order.txt. Order.json. That didn't work. Oh, it's just asking us what's the 256 hash of it. Okay. SHA 256 sum order.json. There it is. Yeah, so it wasn't asking us to find the HMAC yet. Yeah, that worked. open the order.json and change the amount from 1000 to 9000. Okay. So open it up, 9000, save it, close it. You don't have to close it. Just boom, got the new value. And I'll copy that. You can see that the hash changed. I guess that was the point of that. So to show us that the hash changed. All right, using SHA-256 and the key, what is the HMAC of order.txt? So this is what we're looking at earlier with HMAC. And this is 256, and they provide us the key. This, come here, drop that in there. Grab the key, Let's see, get the key here. Drop the key in there. Order.txt. All right, go here, grab it. Come over here, drop that in there, boom. Dang it. HMAC, SHA, HMAC. I don't know if do I have SHA HMAC on here? Maybe that's why. Do I need to install it? I don't know. Key. Oh, it's not HMAC. It's just regular. I think it's just regular. It's just regular HMAC. Let me check. Interesting. I mean, I was able to use SHA-256 up top, SHA-256, and then now it's not letting me. SHA. Oh, maybe I didn't put the A afterwards. HMAC. I was using it up here. SHA. Oh, SHA-some. Maybe that's why. SHA-some. No, it's SHA. All right, let me figure this one out. Okay, I should have backed up my PC, but apparently I had to install hack or HMAC 256, and then I was able to get that information. Oh, yeah, learned that the hard way once. You want to make sure you back up your stuff before you start running commands that are going to install tools. But it worked, so good there. All right, moving on. Oh, we're going on to pkeyutl TLS. Very cool. I'll just close that out. Test 6. All right, I just went straight to the hint on this one. Grab the hint right there, put it in the terminal, in the location of that file. And it's asking, what is the size of public key in bits? Does it give us the size in bits? Don't know. 4096, I believe. Yep, that worked for me, 4096. Tell which year is the certificate valid. So it says right here, 2039. That's not good. It's a long time. All right, 2039. Reason that's not good is because 2039, the encryption that they're using here is probably going to be deprecated, right? So, SHA-256. I don't know if SHA-256 is going to be good by the time you get to that year. The advances in technology, you never know. All right, moving on. Authenticating with passwords. So we have passwords. Use hashes instead of the passwords, more secure. You salt those passwords, make them extra secure. You're auditing a system when you discover MD5 hash to the admin password. What is the original password? Oh, easy. So if this is MD5, then all we need to do is out this and out this. Oh snap! So what am I doing? Close that. All right, hold on. Sorry guys. All right, there we go. So let's go here. Let's exit that. Open terminal. Let's go ahead and they're saying to use MD5 cracking tool. Let's use it. MD5 cracking tool. We can use this one. There's a lot of MD5 cracking tools. It's like pick your choice, I guess. Right? Just make sure they're secure. All right, so I'm just gonna drop it here. I got time for this. Oh, by the way, press enter when you're ready to run that thing. Careful, they got a bunch of ads here. Here it is. That's the password. All right, easy. All right, so in this task, we explore what happens when you log into the website over HTTPS. Clients request server's SSL TLS certificate. Server sends SSL TLS certificate to client. Client confirms certificate is valid. The cryptography's role starts with checking certificate. For certificate be considered valid, it means it is signed. Signing means that the hash of the certificate is encrypted with the private key and trust third party. The encrypted hash is appended to the certificate. If third party is trusted, the client will use third party's public certificate to decrypt the encrypted hash and compare it with the certificate's hash. However, if the third party is not recognized, the connection will not proceed automatically. Once the client confirms the certificate is valid and SSL TLS handshake started, this handshake allows the client and the server to agree on the secret key and the symmetric encryption algorithms, along with other things. From this point onward, all the related session communication will be encrypted using a symmetric encryption. The final step will be to provide login credentials. The client uses the encrypted SSL TLS session to send them to the server. The server receives the username and password and needs to confirm that they match. Following the security guidance, we expected that the server uses a hash version of the password after appending it to a random salt. This way, if the database were breached, the password would not change. Make sure you read and understand the scenario. Correct answer. Cryptography is a vast topic. In this rule, remember we have tried to focus on the core concepts that would help you understand the commonly used term in cryptography. This knowledge is vital to understanding the configuration option of the systems that uses encryption and hashing. Right, and we completed it. Yes, we got through it. So happy. All right, so that was Intro to Cryptography. I'm going to be creating more rooms for this. I'm very much into TryHackMe. It's creating some videos for another platform. We'll not name the platform, but let's just say they weren't too fond of me making videos. So I am going back to try hacking because it works and it's a great platform and it works. And I'm gonna even request that they add this video to the write-ups and we'll see if they add it. I hope so. Would love to help you guys get the flags while also gaining more popularity when it comes to these video introductions because I love doing this. I love teaching and I just want to go through it with my fellow hackers. All right. Anyways, hope you have a good day. Consider liking, subscribing. Danny out.